In our last example, we are given a polynomial that has a quadratic in the top and the bottom. The first thing we're going to do is, of course, factor the quadratic to see if there is anything that we can cancel in terms of common factors and what we can determine are asymptotes. Looking at the top, I can see I have, actually top and bottom, we have a leading coefficient of 1, so we can use our shortcut method. Two numbers that make -8 but add to +2. This gives me x plus 4, x minus 2 in the numerator, and in the denominator, two numbers that multiply to 4 and add to 5 will be x plus 1, x plus 4. So here we have two non-permissible values because we have two things in the denominator. We have that x cannot equal -1 and x cannot equal -4. However, we see that there's a common factor, x plus 4, x plus 4, in the numerator and denominator. This tells me that x plus 4 is a point of discontinuity or a hole in the graph. And because x plus 1 remains, this tells me I have a vertical asymptote at x equals -1. So I cannot cross that boundary. So when I look at my simplified equation, this gives me f of x equals x minus 2 over x plus 1. Down below here, equate the common factor to 0, solve for x to establish the point of discontinuity, right? So the common factor is your point of discontinuity. And then if you substitute the value of x into the function, where is the point of discontinuity? So we're going to take our simplified function and we're going to put the point -4 in to see what is the y value of the whole. So we're going to have -4 minus 2 over -4 plus 1. This is going to give me -6 over -3, which is +2. So the coordinates of the whole, -4 and 2. Okay, always remember that when we're finding the coordinates of the point of discontinuity, we are using the simplified equation, not the original equation. All right, find the x-intercepts and the y-intercepts. So again, when we're looking for an x-intercept, we set y equals 0. When we're looking for a y-intercept, we make x equals 0. So here's our function. If we let y equals 0, we have x minus 2 up top, x plus 1 on the bottom. I multiply x plus 1 on both sides to get rid of this denominator. I get that 0 equals x minus 2. So that means my x-intercept is going to be at the point 2, 0, right? Because I just solved for x here, x equals 2. And then for my y-intercept, I'm going to have y equals 0 minus 2 over 0 plus 1. So my y-intercept is at -2, coordinates being 0, -2. So I have three coordinates that I know for sure: the whole, the x-intercept, and the y-intercept. So now, to find the vertical and horizontal asymptotes, we have to do a little bit of analysis and rearranging. My simplified equation, I'm just going to write it out here. Oopsie, that should be a -2 in the top and x plus 1 on the bottom. I already know that because I have an x plus 1 on the bottom, that my vertical asymptote is going to be x equals -1. Essentially, when I put it into my transformation equation, this represents my h value, right? X minus h. To find my horizontal asymptote, I have to make this look like the transformation equation. So I'm going to split the numerator, x over x plus 1 minus 2 over x plus 1. I want in this piece the top and bottom to cancel. So I'm going to add 1 here, which means I minus 1 here so that I don't change the equation. So this simplifies to negative 3 over x plus 1. So I'm just writing this term first. And here, everything cancels out, so I'm just left with a 1. Okay, so again, if my base transformation function is this, x minus h plus k, I can see from this equation, again, vertical asymptote is at -1, horizontal asymptote is at +1. So horizontal asymptote at y equals 1. So I have 2 more key features of my graph, vertical asymptote and a horizontal asymptote. When I go to graph it, I always start with my asymptotes. Vertical asymptote at x equals -1. There it is. Horizontal asymptote at y equals +1. There it is. Let me zoom out to see where my intercepts are. 2, 0, 1, 2, 0, and 0, -2. And what else? Oh, my whole, -4, +2. 1, 2, 3, 4, +2. Oh, and I shouldn't fill it in because a whole is always represented with an empty circle to represent the whole there. Okay, now I know the shape of the graph is going to be the little C kind of shapes on either side. You'll notice that this time they're both in the second and fourth quadrant instead of the first and third, and this is because of my A value here. I have a vertical or a reflection over the x-axis, so this graph is upside down. That is why my points are on the second and fourth quadrants rather than the first and third. Okay, so here is a sketch of the graph. It says you can check using technology. I'll let you guys do that. You can use your graphing calculators or Desmos. There will come a time where I'm going to ask you at some point to make a slightly more accurate graph. And to do that, you're going to need to choose some points. You're going to need to make a table of values, and you can just choose some x values, put them into this equation, and this will give you the y values. And so you'll have a few more dots that you can put on your graph to make sure that your picture is as accurate as possible. However, this is just asking for a rough sketch using the key points that we can determine from the base equation. And in this case, it was the wholes, it was the asymptotes, and the intercepts. And as long as you make a basic shape that kind of reflects the general shape of the graph, that is good enough. All right, we are all done.